All right, math friends, welcome back. We are on chapter 3.1, Introduction to Integers. Learning objectives. By the end of this section, you will be able to locate positive and negative numbers on the number line, order positive and negative numbers, find opposites, simplify expressions with absolute value, translate word phrases to expressions with integers. Be prepared 3.1. Before you get started, take this readiness quiz. Plot 0, 1, and 3 on a number line. If you miss this problem, review example 1.1. Be prepared 3.2. Fill in the appropriate symbol. Equal to, less than, or greater than. If you missed this problem, review example 2.3. Locate positive and negative numbers on the number line. Do you live in a place that has very cold winters? Have you ever experienced a temperature below 0? If so, you are already familiar with negative numbers. A negative number is a number that is less than 0. Very cold temperatures are measured in degrees below 0 and can be described by negative numbers. For example, minus 1 degree Fahrenheit, read as negative 1 degree Fahrenheit, is 1 degree below 0. A minus sign is shown before a number to indicate that it is negative. Figure 3.2 shows minus 20 degrees Fahrenheit, which is 20 degrees below 0. Figure 3.2. Temperatures below 0 are described by negative numbers. Temperatures are not the only negative numbers. A bank overdraft is another example of a negative number. If a person writes a check for more than he has in his account, his balance will be negative. Elevations can also be represented by negative numbers. An elevation at sea level is 0 feet. Elevations above sea level are positive, and elevations below sea level are negative. The elevation of the Dead Sea, which borders Israel and Jordan, is about 1,302 feet, or 1,302 feet below sea level. So the elevation of the Dead Sea can be represented as negative 1,302 feet. See figure 3.3. Figure 3.3, the surface of the Mediterranean Sea has an elevation of 0 feet. The diagram shows that nearby mountains have higher positive elevations, whereas the Dead Sea has a lower negative elevation. Depths below the ocean surface are also described by negative numbers. A submarine, for example, might descend to a depth of 500 feet. Its position would then be minus 500 feet as labeled in Figure 3.4. Figure 3.4. Depths below sea level are described by negative numbers. A submarine 500 feet below sea level is at negative 500 feet. Both positive and negative numbers can be represented on a number line. Recall that the number line created in add whole numbers started at 0 and showed the counting numbers increasing to the right, as shown in Figure 3.5. The counting numbers, 1, 2, 3, and so on the number line are all positive. We could write a plus sign, plus, before a positive number such as +2 or +3, but it is customary to omit the plus sign and write only the number. If there is no sign, the number is assumed to be positive. Now, we need to extend the number line to include negative numbers. We mark several units to the left of 0, keeping the intervals the same width as those on the positive side. We label the marks with negative numbers, starting with -1 at the first mark to the left of 0, -2 at the next mark, and so on. See Figure 3.6. Figure 3.6. On a number line, positive numbers are to the right of 0. Negative numbers are to the left of 0. What about 0? 0 is neither positive nor negative. The arrows at either end of the line indicate that the number line extends forever in each direction. There is no greatest positive number, and there is no smallest negative number. Manipulative mathematics. Doing the manipulative mathematics activity, quote, number line part 2, unquote, will help you develop a better understanding of integers. And here we have example 3.1. Plot the numbers on a number line. A, we have number 3, B, -3, and C, -2. Here are the solutions. Draw a number line, mark 0 in the center, and label several units to the left and right. For A, to plot 3, start at 0 and count 3 units to the right. Place a point as shown in Figure 3.7. For B, to plot -3, start at 0 and count 3 units to the left. Place a point as shown in Figure 3.8. For C, to plot -2, start at 0 and count 2 units to the left. Place a point as shown in Figure 3.9. And there you have it. If we have some problems, try at 3.1, plot the numbers on a number line, and you can try these at home. Order positive and negative numbers. We can use the number line to compare and order positive and negative numbers. Going from left to right, numbers increase in value. Going from right to left, numbers decrease in value. See Figure 3.10. Just as we did with positive numbers, we can use inequality symbols to show the ordering of positive and negative numbers. Remember that we use the notation A is less than B when A is to the left of B on the number line. We write A is greater than B when A is to the right of B on the number line. This is shown for the numbers 3 and 5 in figure 3.11. Figure 3.11, the number 3 is to the left of 5 on the number line, so 3 is less than 5 and 5 is greater than 3. The number lines to follow show a few more examples. 4 is to the right of 1 on the number line, so 4 is greater than 1. 1 is to the left of 4 on the number line, so 1 is less than 4. Both are true. B minus 2 is to the left of 1 on the number line, so minus 2 is less than 1. 1 is to the right of minus 2 on the number line, so 1 is greater than negative 2. C. Minus 1 is to the right of minus 3 on the number line, so minus 1 is greater than minus 3. Minus 3 is to the left of minus 1 on the number line, so minus 3 is less than minus 1. And we have an example, 3.2. Order each of the following pairs of numbers using less than or greater than. Solution. Begin by plotting the numbers on a number line as shown in figure 3.2. And as we compare 14 to 16, 14 is to the right of 16 on the number line, so we have 14 is greater than 6. B, compare minus 1 and 9. Minus 1 is to the left of 9 on the number line, so minus 1 is less than 9. C, compare minus 1 and minus 4. Minus 1 is to the right of minus 4 on the number line, so you have minus 1 is greater than minus 4. D, compare 2 and negative 20. 2 is to the right of negative 20 on the number line, so 2 is greater than negative 20. And now we have a few try it questions that you can try at home. Find opposites. On the number line, the negative numbers are a mirror image of the positive numbers with 0 in the middle. Because the numbers 2 and minus 2 are the same distance from 0, they are called opposites. The opposite of 2 is negative 2, and the opposite of negative 2 is 2, as shown in figure 3.13a. Similarly, 3 and negative 3 are opposites, as shown in figure 3.13b. Opposite. The opposite of a number is the number that is the same distance from 0 on the number line, but on the opposite side of 0. Example 3.3. Find the opposite of each number. A is 7 and B is minus 10. Solution. A, the number, minus 7, is the same distance from 0 as 7, but on the opposite side of 0. So minus 7 is the opposite of 7 as shown in figure 3.14. B. The number 10 is the same distance from 0 as minus 10, but on the opposite side of 0. So 10 is the opposite of minus 10 as shown in figure 3.15. And we have a few try it problems on your own. Opposite notation. Just as the same word in English can have different meanings, the same symbol in algebra can have different meanings. The specific meaning becomes clear by looking at how it is used. You have seen the symbol dash or minus in 3 different ways. 10 minus 4, between two numbers. The symbol indicates the operation of subtraction. We read 10 minus 4 as 10 minus 4, minus 8. In front of a number, the symbol indicates a negative number. We read negative 8 as negative 8. Minus x. In front of a variable or a number, it indicates the opposite. We read negative x as the opposite of x. Minus minus 2. Here we have two signs. The sign in the parentheses indicates that the number is negative 2. The sign outside the parentheses indicates the opposite. We read minus minus 2 as the opposite of negative 2. Opposite notation. Minus a means the opposite of the number a. The notation minus a is read the opposite of a. Example 3.4. Simplify minus minus 6. And the opposite of minus 6 is 6. And we have a few try it problems. Couple. Integers. The set of counting numbers, their opposites, and 0 is the set of integers. Integers. Integers are counting numbers, their opposites, and 0. We must be very careful with the signs when evaluating the opposite of a variable. Example 3.5, evaluate negative x. A, when x is equal to 8. B, when x is equal to minus 8. The solution, A, to evaluate minus x when x equals 8, we substitute 8 for x. And as you do so and simplify, you find minus 8. B. To evaluate minus x when x equals minus 8, substitute minus 8 for x. Substitute minus 8 for x, and you notice the parentheses and the substituted value inside, and we simplify and we get 8. Some try it problems. Now we will simplify expressions with absolute value. We saw that numbers such as 5 and minus 5 are opposites because they are the same distance from 0 on the number line. They are both 5 units from 0. The distance between 0 and any number on the number line is called the absolute value of that number. Because distance is never negative, the absolute value of any number is never negative. The symbol for absolute value is two vertical lines on either side of a number. So the absolute value of 5 is written as absolute value of 5. And the absolute value of -5 is written as the absolute value of -5, as shown in figure 3.16. You'll notice in both of these, the distance to 0 is 5. The definition of absolute value: the absolute value of a number is its distance from 0 on the number line. The absolute value of a number n is written as the absolute value of n. Absolute value of n is greater than or equal to 0 for all numbers. Example 3.6. Let's simplify a, the absolute value of 3, b, the absolute value of -44, and c, the absolute value of 0. And for a, you find 3 is 3 units from 0. B is 44 units from 0. And C is already at 0. We have some triad problems. We treat absolute value bars just like we treat parentheses in the order of operations. We simplify the expressions first. We simplify the expression inside first. Here's example 3.7, where we evaluate a, absolute value of x when x equals -35, b, absolute value of -y when y is equal to -20, c, minus absolute value of u when u equals 12, and d, negative absolute value of p when p equals -14. And to do this, we substitute for a to find absolute value of x when x equals -35. You substitute in -35, take the absolute value, and we get 35. To find the absolute value of -y when y equals -20, you'll notice that the substitution of -20 for y is in the parentheses. And when we simplify, it becomes +20. Taking the absolute value becomes 20. For c, to find minus absolute value u when u is equal to 12, you substitute in 12 for u, take the absolute value, and since the absolute value only affects the inside and the negative is outside, we get -12. Here, to find minus absolute value of p when p is equal to -14, we substitute in -14 for p, and again, because the absolute value affects the inside of the absolute value, that is the -14, that becomes positive, taking the absolute value, and so we get -14. Notice that the result is negative only when there is a negative sign outside the absolute value symbol. We have a few, or rather some triad problems, and another set of examples. Fill in less than, greater than, or equal for each of the following. Okay. Solution. To compare two expressions, simplify each one first, then compare. So here they simplify for A, the left and the right side, and then they order it. And you find that 5 is greater than -5. For B, similar process. We simplify both sides. The left is already simplified. The right absolute value can be taken, produces -8, and you get 8 is greater than -8. Something to note about the math is notice that you can read it backwards. That is to say, -8 is less than 8, which is also true. And you could do that for this also. -5 is less than 5. Or you could say 5 is greater than -5. C has us also simplify the right side. Minus minus 9 becomes -9 on both sides. They are equal. Or rather, minus the absolute value of -9 is -9. And they're both equal. D. The minus absolute value of -7 is -7, and we get equality. Okay, let's try it for these problems. Absolute value bars act like grouping symbols. First, simplify inside the absolute value bars as much as possible. Then, take the absolute value of the resulting number and continue with any operations outside the absolute value symbols. Example 3.9. Let's simplify these two problems. Solution. For each expression, follow the order of operations. Begin inside the absolute value symbols, just as with parentheses. So we get the absolute value of 9 minus 3. Simplify inside the absolute value sign, and we get 6. That is the absolute value of 6. Take the absolute value, and we get 6. For B, 4 times the absolute value of -2. We start on the inside, take the absolute value, and we get 4 times +2. That gives us 8. And we've got to try 4 try-it problems. And example 3.10, where we simplify this expression. For each expression, follow the order of operations. Begin inside the absolute value symbols, just as with parentheses. Simplify inside each absolute value sign, and then subtract. You notice the inside are all positive, so this becomes 15 minus 11, and that's 4. Example 3.11, we simplify another expression. Solution. We use the order of operations. Remember to simplify grouping symbols first, so parentheses inside absolute value symbols would be first. So here we look on the inside of this expression, that would be 6 minus 2, and that becomes 4. Then the most inside to that would be minus 3 times 4, which becomes minus 12. And then we have 9 minus 12, and that's 7. Then we can take the absolute value, and that becomes 7. But the negative is on the outside, so it just carries through. And then we subtract and get 17. And we have a few triad problems, or a couple. Translate word phrases into expressions with integers. Now we can translate word phrases into expressions with integers. Look for words that indicate a negative sign. For example, the word negative in -20 indicates minus 20. So does the word opposite in the opposite of 20. Example 3.12. Translate each phrase into an expression with integers. A. The opposite of positive 14. B. The opposite of minus 11. C. Negative 16. D. 2 minus negative 7. So the solution to this is a direct translation of the written. Minus 14 is the opposite of 14. The opposite of minus 11, you started the beginning here with the minus 11, or rather the minus, and then parentheses minus 11 gives us positive 11. When they ask for negative 16, it can be written directly, and D is an expression 2 minus negative 7. Some triad problems. As we saw at the start of this section, negative numbers are needed to describe many real-world situations. We'll look at some more applications of negative numbers in the next example. Example 3.13. Translate into an expression with integers. A. The temperature is 12 degrees Fahrenheit below zero. B. The football team had a gain of 3 yards. C. The elevation of the Dead Sea is 1,302 feet below sea level. D. A checking account is overdrawn by $40. Solution. Look for key phrases in each sentence, then look for words that indicate a negative signs. Don't forget to include units of measurement described in the sentence. A. The temperature is 12 degrees Fahrenheit below zero. B. 0 tells us that 12 is a negative number. Minus 12 degrees Fahrenheit. B. The football team had a gain of 3 yards. A gain tells us 3 is a positive number. C. The elevation of the Dead Sea is 1,302 feet below sea level. Below sea level tells us that 1,302 is a negative number. Minus 1,302 feet. D. A checking account is overdrawn by $40. Overdrawn tells us that 40 is a negative number, giving us minus or negative $40. Some triad problems and media references, as well as more practice. You're welcome to practice these problems from chapter 3.1, and this concludes our chapter 3.1, Introduction to Integers. So you'll see we've got plenty of practice problems. I encourage you to practice some of these on your own and get comfortable, especially with the word problems that can take some interpretation. Be patient with yourself and be persistent. All right. Thank you very much, math friends. That is chapter 3.1, Introduction to Integers.